Hello and welcome to the review tutorial for Process Choice. When we think about different manufacturing processes, we generally consider that there's four major types that companies have available to choose from: job shop, batch, assembly lines, and continuous flow. Each of these four types has its own strengths and weaknesses, and companies have to choose which of these four based on the manufacturing environment that they're going to be in. And for simplicity, what a lot of times what we say is that the decision on which style of manufacturing process to adopt is contingent just upon two major dimensions: how much volume there's going to be, and how much variety is required by customers in terms of product variation. One really neat thing that matrix that helps us figure out which process is best for us is the Hazen Wheelwright product matrix. Here on the horizontal axis, we graph product variety required by the customer. The origin would mean low or almost no variety, and then moving to the right would be high variety. And then on the vertical axis, we have low volumes all the way up to very high volumes. So basically, the first type, continuous flow, generally does very well when there's very high product volume and very low product variety. Generally, it's used in a one product type environment. The assembly line would come next. It still is very good at high product volumes, and it can start to incorporate a little bit of variety, but it doesn't have the capability for all that much variety. So, for example, Ford has an assembly line for their Ford Mustang car, and while it can make any type of Mustang convertibles, ones with different types of engines, different types of options on the interior in terms of stereo and whatnot. That assembly line also can't make, say, a completely different product like the F-150 pickup. Moving down to the right a little bit more, we have batch production. This tends to be low to medium in terms of product volume and starts to give the customer a lot more variety in terms of customization. And then all the way in the bottom right diagonal, we have a job shop environment, which is excellent at giving the customer lots of customization. And generally, job shops are used on very low volume type of material. If you took class with me, you may remember we watched some videos so you could see some of these processes in action. And here's a few more. For the assembly line, you can look at the YouTube video to see how BMWs are made. For football helmets, for the batch methodology, we watched a video on football helmets. And for Job Shop, we watched the video on pinball machines. So if you don't remember those videos, you might pause the recording now and the tutorial now and watch the videos so we have it sort of makes more conceptual sense. In comparing the four processes, we could do it on multiple dimensions. So some examples of job shops would be the pinball machine video, where that factory was making any type of pinball machine imaginable, or something like a custom wedding dress where every customer has a very unique style of dress they want and they have unique measurements and so forth. In terms of batch, we watched the football helmet video. A lot of us probably have made cookies at one point in our life, or our parents did. Generally, those are made a batch at a time. Maybe you'll make a batch of chocolate chip cookies and then make a batch of snickerdoodles or something like that. And if you've ever toured a whiskey distillery, that's also made in a batch process. In terms of assembly lines, the assembly line was the modern assembly line, at least, was invented by Ford for cars. Computers are also assembled using an assembly line, and you can even think of the UD cafeteria as an example of a assembly line and more of a service facility. In terms of continuous flow, again, these are very high volume, very low variety. Most paper mills follow a continuous flow, so you can think about a paper mill just essentially makes ream after ream of white paper. They would fit this category. Steel mills are basically the same way, and paint is also done on a continuous flow process where even today paints are they just make the standard white paint, and then say at Home Depot or Lowe's they would add the pigment to it there. So the paint manufacturer is essentially just making one type of product. Job shops are very low volume, and that increases all the way up to continuous flow, which is the highest volumes. In terms of product variety that the customer or how customized the product is, for example, a custom wedding dress is really has an infinite amount of variety, whereas if you on the other side, continuous flow, you have very little choice, say in what type of paper, computer paper or something that you want. In terms of fixed cost, job shops generally have very low fixed cost. They don't require all that really specialized or expensive equipment. Continuous flow, on the other hand, and assembly lines do require very high speed, highly technical equipment like robots and stamping presses, and that equipment tends to cost millions of dollars in some cases, so fixed costs are very high. Variable costs, which we generally think of as direct labor cost, in a pinball in job shops, they tend to be very high because most of the work is done by human hands as opposed to robots. In continuous flow, on the other extreme, variable costs tend to be very low because we don't have much human labor. Lots of the human labor involved in assembly lines and continuous flow is quality assurance or material handling. In terms of the types of equipment that's used in the different processes, shops use a very general equipment. So in the pinball machine example, they used very general stuff like hammers, torque wrenches, soldering irons, and so forth. Equipment that can be used not just to build pinball machines, but basically assemble just about any product. Whereas in continuous flow and the car example, for assembly lines, they use very specialized fast pace equipment that really is only good at doing one type of thing. In terms of the job flexibility required, job shops, because there's so much customization of product and every product going through the system is different, workers have to be highly skilled and highly flexible. Whereas assembly lines and continuous flows, because a worker is basically working on one standardized repetitive task, they don't need quite as much flexibility. Manufacturing strategies associated with them. Job shops generally use make-to-order strategies where the firm doesn't even begin to purchase materials, let alone make the final product until the customer actually specifies what they want. Job shop and assembly lines a lot of times will use assemble to order. For example, Dell will build all of their components ahead of time. You know, their processing chips, their video cards, their hard drives and so forth. They'll do that ahead of time, but they'll wait for the customer to call and place their order before they actually assemble it. And then continuous flow generally uses a make to stock strategy where they make, because it's only one standardized product, they make it ahead of time and ship it to retailers to sell. In terms of layouts that are used, job shops tend to use process layouts. This means they'll categorize their work facility into different areas based on the process. So they might have one area of their facility dedicated to welding, another part dedicated to stamping, another part dedicated to general assembly, another area for painting, and so forth. On the other side, where assembly line and continuous flow, where there's generally just one type of product made, like the Ford Mustang, they'll lay out their entire facility around a single product. So again, the Ford Mustang plant, it can assemble Mustangs, but it can't assemble the family sedans or the pickup trucks and so forth. In terms of the managerial focus, in job shops, the most complex thing is the scheduling and routing. So figuring out, because every product is unique, it has to go through its own unique process. So managers have to figure out what workers are needed in what areas, what material needs to go to what areas, and so forth. So trying to route the product, the equipment, and the labor is the major focus. Whereas continuous flow and assembly lines, because the assembly line is already laid out for you, there really doesn't need to be any scheduling. The only area that you need to schedule is the first station on an assembly line, because every single station after that does product in the same exact order. So what they try to do is focus on getting and keeping very high utilization. So they focus on stuff like assembly line balancing to make sure every worker is utilized, say, at 90 or 95%. In terms of what competencies the different processes are good at, job shops are very good at customizing products for customers, so lots of flexibility. They generally are very good at high performance quality items. And they also tend to be very good at customer service, again, because they require or they give the customer lots of flexibility and customization. Assembly line and continuous flow on the other extreme, they're very good at producing stuff in low cost. Um, they do provide lots of quality, but it's more in terms of consistent quality than, say, high performance quality. So think of a ream of computer paper, right? All we really care about is that the quality is consistent from one sheet to the next. And they also, because they can use make to stock and assemble to order strategies, they're very good at delivery speed. Recently, though, we see these four processes on our matrix here, and we see that there's a trade-off between product volume and product variety. Well, in the last 10 or 15 years, something has popped up called mass customization. This is where we try to produce in very high volumes and still give customers lots of flexibility or customization of the product. Dell kind of pioneered this in how they made computers, right? Dell was kind of made their name by having very low cost computers, but letting the customer specify the components that they wanted, and they were basically able to build any computer for any customer and get it to their door in 5 working days, which was kind of amazing. And they do this by what's called modular design, where they'll build the modules beforehand, and then as the customer orders it, they'll just assemble the modules together. So in this tutorial, again, we talked about our 4 major process types: continuous flow, assembly line, batch, and job shop, and we contrasted them on several different dimensions, everything from costs associated with them to the types of competencies they're very good at.